All right, good morning, everyone. Welcome at the RiskKAN Early Warning Systems webinar for a change on a 9 a.m. here in Europe, because we have Dr. Andrew Tupper today with us, who's based out of Australia. Dr. Andrew Tupper is a meteorologist and the principal of Natural Hazard Consulting, where he focuses on improving multi-hazard early warning systems from international to local level. And he's particularly interested in bridging between disciplines. He's also affiliated with UCL's Warning Research Center, and he's a visiting scientist at the Bureau of Meteorology in Melbourne. Today, Andrew will talk about strategies for connecting the natural hazards and multi-hazard early warning systems. And I'll link again his paper in the chat. And Andrew, the floor is all yours. Well, thank you for being here.
Oh, thank you very much, Marlene. Yeah, appreciate everyone coming. I'm going to talk a little bit on this introductory slide, and if we have any more people come along while I'm talking, they can probably catch up with what we're talking about. Let's see. On this slide, I've got a loop showing satellite imagery of the Mount Pinatubo eruption in 1991. When I was a junior meteorologist. Very junior meteorologist, known as metlets in the lingo of the time, as in gone through university but not yet considered operationally competent. And I remember during our training course, which is in Melbourne in Australia at the Bureau of Meteorology, being shown these amazing images from Mount Pinatubo. And the images were every few hours from the Japanese GMS satellite, but that was amazing technology at the time. And of course, one of the astonishing things about the Mount Pinatubo eruption was that, was that the eruptions happened during the impact of a Typhoon Yunya, or locally known as Daiding, which was forecast and did cross Luzon just as the volcano came into its climactic eruptions. So it's, I think, probably still one of the very best examples of complex, compounding, cascading events, because so many things were going on. The typhoon's wind field altered the distribution of ash and gases from the eruption, with the coincidence as it crossed in the island just as it was really going off. But also the typhoon brought an enormous amount of rainfall, and that moisture interacted with the eruption cloud. It would have also affected the height of the eruptions, but the major impact that it had was to impact the death toll in terms of roof collapses from wet volcanic ash, and also the generation of lahars, volcanic mud flows. That was a remarkable event until this year's eruption, which we'll talk about in a ticket. It was the largest, in terms of the tallest, volcanic cloud to be observed by satellite. At the time, it was observed as 40 kilometres. The technology then was not as good as now, but it was a very sort of broad set of eruptions too, with the umbrella cloud pushing well upstream against the prevailing wind, and the sulfur dioxide cloud and the aerosols circling the world and causing a temporary cooling of the climate. The eruptions at Pinatubo also caused over 20 aircraft encounters and a cost, I think, of about around about US $100 million. So it was also a very interesting early incident in what became the International Airways Volcano Watch, the warning system for volcanic clouds. And of course, despite the evacuation of tens of thousands of people, which was considered a major success and was genuinely a major success, there were hundreds of deaths from the eruption, and then deaths in the succeeding years as lahars kept flowing from the mountain and burying villages. So despite a wonderful warning performance by the Philippine authorities, assisted by the United States and others, it was still a devastating event. So just fast forwarding to this year, and of course the January 15th eruption of Hunga Tonga Hunga Hapai is another great example of a complex event with the eruption. I'm showing the full disc here. I like to show the full disc just because if we zero in on the eruption itself, we miss a lot of the complexity about what's going on. But this loop shows the preceding day's eruptions and then the major eruption, which reached even higher through the stratosphere, releasing a lot of water vapor. Fortunately, only causing 4 lives lost in Tonga, a few more lives lost off Peru, and various impacts around the Pacific Basin with the meteor tsunami that was created, and also causing impacts on land from ashfall and at sea from pumice. So a whole lot of things going on. One might think that in the 31 years between these two events, we would have nailed lots of things about how to handle these complexities, how to handle major eruptions with multiple impacts. And I guess one of the arguments in the paper that's been shared is that we're not proceeding far enough, and we're not going to proceed far enough or fast enough without a structural change to the way we do things. Just before I continue, by the way, I should have acknowledged my co-author, Adele Bear-Crozier, who couldn't be here today, but she's the volcanologist in the paper. I was a meteorologist in the paper. Okay, so just stepping back from eruptions at the moment, just a quick reminder about the Sendai goals in the 2015 to 30 framework that we have all signed up to and that we all report on. And one of those goals is to substantially increase the availability of and access to multi-hazard early warning systems and disaster risk information and assessments to people by 2030. Now, everyone in this audience knows that, so I'm not going to dwell on it too much. But it's a pretty challenging goal. And I think, as we all know, in the global assessment report this year, we're falling behind in all of these goals. And we need to think about how we can accelerate progress and demonstrate that we are accelerating progress, work out what's impacting things. And there's quite a strong report on that released by UNDRR earlier this year. And also this year, we've had the additional stimulus of the announcement on World Meteorological Day by the UN Secretary General of the Early Warnings Initiative, where he asked the World Meteorological Organization to lead the effort to ensure that every person on Earth is protected by early warning systems within 5 years. With the action plan then launched at COP27 just recently. I wasn't there, but I understand it was very well received. But 5 years is not a long time. Even if we only concentrated on direct climate hazards, it would still be really challenging. And I'll talk about which things we concentrate on a little bit later, perhaps. And before I proceed any further, I also want to have just a bit of an aside. Using this beautiful diagram, thank you, that I'm speaking from the technocrat perspective, and I think most meteorologists with operational background like me would tend to naturally do that because we're all worried about systems and operations and getting products out and so on. But I want to acknowledge that this is about the users, and early warning systems only work when they have the right facilitating environment and when all the core elements are in place. So really what I'm talking about here is not the whole process, but it's more about the science contribution to the process that helps everything else work. And I want to assert that it's really easy to talk about just one bit of it as though that's the only important bit in the process. So, if we're focusing on using traditional knowledge, for example, then, and that's our world, we'll tend to talk about that quite a lot. If we're talking about putting out cyclone warnings, and it's all about cyclone warnings. And I feel that it can be hard for us to sort of see the other bits of the process and to understand how it all works together. But if I was going to talk about the importance of the science bit of the process, I'd say there are a few things that science really brings to a warning process. One is the understanding of what could happen. And here's this slightly blurry photo of a hazard map being used in planning in Indonesia. This is for a gug in Bali. To inform, the basics of disaster preparation and response, and to work out where you're going to concentrate the effort. At the tactical level, it's absolutely essential that science informs people on the ground who are dealing with the hazard. And I think bushfires, this is from the so-called Black Summer a couple of years ago in Australia. Bushfires are one of the critical examples of that, because it might come down to, will the wind change happen in the next 15 minutes, or will the wind change be another hour? Do we evacuate all our crews now? Do we abandon our defence of this town? Do we risk the firefighters' lives by leaving them longer? And that comes down to really precise modelling and warning and trust, of course, that's given to the firefighters. It's also really important that we use science to help bring together a coherent message, so that what goes out to the people is the most that we possibly know about a situation. I enjoy this picture because it's got a lovely bit of miscommunication on it in terms of poor media understanding of what a Category 4 cyclone is. Cell is a term that tends to get used for thunderstorms occasionally, and it's nothing like the scale of a tropical cyclone. But the science is an essential part of that in describing what we know. And science, I believe, is also a really important part of the credibility of a situation. So, even if you're in a situation with poor leadership, for example, it's important that people understand that there is good science that they can follow, even if the messages coming from the top might be a bit conflicting. And that's the last I want to show of that man. Right, so moving back to volcanoes, and here is where I apologise to the volcanologists in the room. Please feel free to just butt in the chat and correct anything I say. But a simple summary of various volcanic hazards using some United States Geological Survey pictures. Hopefully they're all at Thanksgiving or preparing for it, so they won't be too worried about my use of them. But of the many volcanic hazards, as a meteorologist, one of the interesting things for me is that many of them are affected by the weather, or even impact the weather. Now, the way that I came into this area was through the International EWS Volcano Watch, and so that is all about drifting volcanic ash, and obviously that's about the wind and dispersion of the ash. It's also about the rise of the cloud, because the rise of the cloud depends on the height of the tropopause. It depends on the instability of the atmosphere. And so you can't separate the meteorology from that. Likewise, the ashfall depends on the wind direction and the atmospheric conditions, and ashfall is a really major factor in a lot of volcanic eruptions and the impacts on the ground. Acid rain similarly. Lava dome collapses interesting because some of them are triggered by heavy rainfall. And that for me was kind of unexpected to learn about, but it kind of makes sense. Lahars, obviously, anything to do with water and depends on rainfall. And then on the sort of Hawaiian kind of picture, some of those are repeated there, but you've got things like volcanic smog or VOG, which is a constant kind of hazard. And you've got all the ocean effects. Tsunamis aren't in these pictures, but you've got many different ways that a volcano can generate tsunamis. And then you've got local effects like explosions and lava haze as the lava enters the water and so on. So there's a lot going on where you kind of need meteorologists to be working to support the volcanologists in dealing with the hazard. And from the climate perspective or the climate change perspective, the connections are there as well. I've mentioned some of them, but if, for example, the climate of an area changes, then you would be expecting to change the climatology of the ash plumes coming from an active volcano. Maybe not by much, but if the prevailing wind direction tends to change over time, well, that will change where the volcano is impacting. And similarly with ashfall, if the moisture profiles or the tropopause is changing. And then for those rainfall affected things, lava dome collapses, lahar occurrences and flank collapses. There's a recent paper which I really recommend about this. And very definitely volcanoes are sort of in field when we're talking about climate hazards. And then obviously with tsunamis, anything that's going to increase sea level is a climate issue as well. Right. And then there's the issue of integrated multi-hazard early warning systems. And I've got a few examples here of why when we talk about these hazards, we can't just talk about them one by one by one. We need to talk about integrating the hazards. So there's a particularly cutting article that I recommend reading. I'm not sure that the article is completely fair, but it's still worth reading, by Jonathan Lasser, written after the Semeru tragedy in December last year. And he's essentially zeroed in on the cracks between the volcanological agency, the meteorological agency, and the emergency management agency, and dealing with secondary explosions from lava dome collapse at Mount Semeru. I know that this was an eruption where quite a few people died with a reasonably unexpected event. So the language used in that quote is really strong, an elitist bureaucratic procedural text that has nothing to do with public safety. And I think we would tend to find that uncomfortable, but it may not be wrong when you think about a person expecting to be looked after by government around this very dangerous hazard and finding that no one's taking responsibility for something that combines a couple of sciences. So another example of things not quite working at the moment is in the marine sector. And a lengthy quote here, sorry about the length of the quote. This is from Paul Cragg. For those who have been to any Cities on Volcanoes conferences, Paul has come to at least a couple of those in his own time as a mariner, basically saying, look, there's this hazard for marine services and I'm searching for ways that we can address this because no one seems to be doing anything about it. And again, quite a cutting quote there, hundreds of lives and tens of ships lost at sea through eruptions, while we're spending all the time looking at the aviation hazard and not on marine. Now, there are some arrangements in marine guidelines about volcanic hazards, but it's really not much, and it's not backed up by much in the way of procedure. So there's an obvious gap there that we could be filling, which is again in this kind of mixed space. Another reason why we need to treat systems together and not individually is, of course, from the user perspective, we want them to have as simplest system as possible. This is a nice Australian paper from last year from a couple of South Australian Regional Fire Service researchers. So the complexity of the current warning leads to reduced awareness, lack of comprehension, and people not undertaking designed behaviours. Again, that's pretty strong. So if we throw up a whole lot of complexity and confusion, the people don't respond as well. And lastly, we need to treat these hazards together, because it's only through that that we can achieve economies of scale and resource sharing. And here I'm putting, this is just like a piece of the pie, but a magnificent example from the World Meteorological Organization of the global data processing and forecasting system, where we've got designated centres all around the world creating and distributing numerical prediction for a whole lot of purposes, so that not every country in the world has to run their own modelling in their own supercomputers. And there's been a lot of work recently to refresh that system, to make it as user appropriate and friendly as possible. That work continues. And the system does a whole lot of things for supporting tropical cyclone forecasting, nuclear emergency response, non-nuclear emergency response, ocean wave prediction, severe weather prediction, marine services, the International Airways Volcano Watch,
the computer,
sand and dust storm forecasts, and so on, and a whole lot more. And there are lots more possibilities in the future for that system. So you can only do that when you're organised in a way that efforts are not being needlessly repeated, and there's enough trust that things will be operationally happening. All right, so from all of that, I'm going to make a few assertions. One is that anytime there's a major early warnings initiative, it must be or become a multi-hazard early warnings initiative. It doesn't matter if it's announced in the climate context or in response to a particular disaster, but ultimately, because of these sort of overlying factors, we're going to be pushed back to the wording of Sendai, multi-hazard early warning systems. We're not going to be worried about one discipline only, because that doesn't work. So the Early Warnings for All initiative, a wonderful initiative, and it will need to eventually consider all these multi-hazard things, even though the focus has come out of climate. The next point is that we have to make this seamless if we're taking a user-centered approach. And therefore, we're going to be creating new warning systems and reshaping existing systems to suit. More on that later. And lastly, because many of these hazards, and I'm talking in the volcanic context particularly here, many of these hazards are transboundary. So our approach has to be transboundary as well. We can't do this at a national level and then work out how to join it up later, because that's really quite hard to do. And I might talk more about that if I've got time. But doing this is doing this all, not just joining up the systems, but all of it is really hard work. It takes literally decades to create a good international warning system, let alone a good multi-hazard international warning system. So as I said earlier, my involvement with international warning systems, a lot of it has been in the International Airways Volcano Watch. Now that came into being rapidly in international terms in the mid-80s. It's 2022 now, and there are still many things to be done with that warning system. And that's been pursued with, great single-mindedness by many of the people involved. And you could name a whole lot of other things. I'll talk about a bit more in a tick. So this is not about what any one individual can do, but it's how we work as a collective to make our warning systems better. All right, so I just mentioned the International Airways Volcano Watch. Here's an example of complexity. This is a simplified diagram. The number of players that you need to have in a system to deal with one volcanic hazard. So volcano observatories, area control centres, meteorological watch offices in every country, volcanic ash advisory centres, 9 of them around the world, med offices, airlines, the client, and then sort of non-government players, and then various sort of accommodations that have been made. So, for example, the Smithsonian has got a role in the diagram, even though you wouldn't normally consider that as an operational institution. And thank you to the USA for the Smithsonian's role. Volcano observatories we'll talk about more, but they are asked to do quite a lot, but often they are really quite poorly resourced. And yeah, lots of pieces in this system, and of course it doesn't always work very well. So that's one of the systems that we would need to join with other things to make a well-integrated multi-hazard early warning system that involves volcanoes, meteorology and volcanology. Another one is, sorry, I should have said two, beg your pardon, the International Airways Volcano Watch. The lead on that is the International Civil Aviation Organisation, ICAO, who work with WMO and others. For tsunami warning systems, the lead is the International Oceanographic Commission of UNESCO, working with WMO and others. And again, that's a really complex system, or a set of complex systems, because there's a different warning system in every ocean basin. And with a real focus on earthquakes. So volcanoes, as we have seen numerous times, volcanoes have tended to slip through the cracks in the tsunami warning systems. And the tsunami warning systems have got their own set of challenges, again, very complex, decades to develop, lots of equipment maintenance and so on. But it's one of those systems that we need to bring together more closely into the volcanic world. And a non-volcanic one, but since I started with a typhoon hitting the Philippines, I should mention the amount of work that's gone into tropical cyclones. And if we want to handle an event with a volcano and a typhoon or tropical cyclone, then we would need to know how that system works too, and work with the people who are running that system. I'm not trying to make this a nightmare, but to illustrate just what a challenge this is. Even this system itself, and you know, I've had my fair share of cyclone events, but this is an example here where tropical cyclone Gita, which caused a lot of damage, particularly in Samoa and Tonga. This system crossed the international date line. The international date line, of course, is not just a nice straight line in that part of the world. So warnings would have been going out for different days of the week to different countries. Countries worked very hard to keep their warnings consistent. The lead was taken by Nandi in Fiji, with the Regional Specialised Meteorological Centre there, but every country needed to sort of work to keep its citizens safe and to put out local warnings and so on. So it's a really complex process just for a single, you know, well-defined system. And thanks, Estelle, I just saw the note on GMS. Cheers. Right, so all that happens within the broad context of the United Nations system. And I realise this horrendogram is probably a little bit hard to see, but you know, it sort of sketches out the components of the United Nations system. Many of the agencies listed are not as large and powerful as we might think. Just zooming into the specialised agencies here, we find the World Meteorological Organisation, UNESCO, International Maritime Organisation, International Civil Aviation Organisation. Down there in the bottom left, we've got UNDRR. These organisations, and I hope I'm not misconstruing this, are full of people who work extremely hard to bring very different types of thinking together across the world, and to manage complex diplomacy and gain agreement that helps us move, in this case, warning systems forward. And they're flat chat doing that. they, are often going to take a while to help anything to happen, and they need assistance from the global community to make anything happen, because they don't have the power to just wave a magic wand and say, make it so. So in this system, WMO is coordinating hydromet, which is the great majority of natural hazards. IOC UNESCO, as I said, coordinates tsunamis. But there's no real UN level coordination for other geohazards. There's interest in a couple of areas, but there's not that sort of operational sense that you would get in WMO, or this is how we run warning systems. So this is a major issue when we talk about how we would negotiate international agreements for cross-boundary hazards. In saying that, I want to acknowledge the science associations of the world, and particularly in this case, the IOGG, and the member association, IFC, Volcanology and Chemistry of the Earth's Interior, of IOGG, because IFC is basically a volunteer organisation, have taken on a lot of the work that you would otherwise expect to be seen done in the UN system. So as an example of that, when the International Airways Volcano Watch was created, there was a lot of discussion, again, back to the mid-80s and the 90s, about, well, how do we connect with the volcanologists? And what was written down initially was the World Organization of Volcano Observatories, WOVO, which is one of the commissions of IFC. We're very fortunate to have Jill Jolly here as co-leader of WOVO. I'm sure she won't mind me saying that WOVO, as a volunteer organisation of very busy people, has a limited capacity to do all that much, because there's no budget, and it's all about what can we do with goodwill. And the same with IFC in general. Wonderful people, they get a lot done, incredible amount done, with not much in the way of resourcing, and they bring the world's volcanologists together, but they can't do the job that you would expect of a UN agency. So that has been a continuing challenge of how do we organise ourselves in this way. And again, I do want to acknowledge the really wonderful work that's been done by IFC people to not only help with the sort of things like the International Airways Volcano Watch, but to share the incredible knowledge of the volcanologists on how you warn for volcanoes, which can be quite challenging to meteorologists like me that are used to sort of different ways of working things out. Okay, so how do we fix this? Because I'm saying it kind of needs fixing. Well, again, you don't wave your magic wand and just say, well, we'll change the UN. We're not creating a new UN agency that looks after volcanoes. It's just not going to happen. So we're going to need a more subtle approach to help sort of raise the level of geohazard coordination into the UN system. So in our paper, what we're suggesting is we start with a ground-up approach, choosing key countries. So again, this is back to the volcano example. It would apply to some other hazards as well. We need to understand that it's not going to be done by other people remotely. It's about what we can do to create a groundswell of support. And then to develop coalitions of national agencies to help bring together coalitions of international agencies. So international agencies have representatives from countries. So for example, WMO's got permanent representatives from the hydromet services. Some of those permanent representatives actually already have responsibility for volcanic monitoring. Japan, for example, Iceland, Vanuatu. And so that's kind of easy because they're across it. But there are other countries where you've got really strong agencies that are in great relationships, but where the representation is different. So a good example would be the USA, where the United States Geological Survey is one of the world's leading agencies in this area. But of course, the National Weather Service is what is represented at WMO. New Zealand, another lovely example. We have all the wonderful GNS. So how do those agencies work together to increase the mutual understanding at international level of the kinds of things that we could do on a global basis? That kind of process would be assisted a lot by what we do as individuals, wherever we are in the systems, whether we're academics or working for government or in the international space. And okay, this I want to be a little bit careful, but not too careful. In my experience, I think there are many examples of where our behaviour as individuals and agencies is not as collaborative as we really need to be able to do multi-hazard early warning systems. And usually that would just be because of not understanding the other. Sometimes it's because there's competitive behaviour between agencies. And I could think of many countries and examples that I won't share where that's really obvious, where people need to be working together and simply don't because they're regarding it as a zero-sum game. We need to find ways to grow our multi-hazard community to improve the level of ongoing investment into that community. Governments do not like agencies that are at each other's throats. They don't reward that kind of behaviour. They reward agencies that are clearly collaborating for the common good and trying to achieve outcomes that are greater than any one agency. And the same applies to development agencies as well, in my opinion. It's much easier to put aid money into projects that have a high degree of success and where you can see the relationships are already all sorted out. So it's our responsibility to work on those relationships and help sort them out. So what's our future vision? What would we be trying to build if we were trying to make progress in this space? I want to suggest a few things. Can we reasonably expect that every active or potentially active volcano should be instrumentally monitored? That's already in the guidance coming from the International Civil Aviation Organization. It would be nice if we were able to achieve that, because if we could achieve that, then hey, that would help every particular hazard. It would help ashfall, it would help tsunami, it would help everything. And again, the volcano observatories of the world are not necessarily resourced to the degree that they should be. Could we agree that the cost of that monitoring should be shared? It would be ridiculous if we expected every Pacific Island country, for example, to bear the full costs of volcanic monitoring for eruptions that might affect the whole ocean basin. Tonga would be a really good recent example. Tonga's budget does not permit for the degree of monitoring that is really required to be totally on top of what's going on with those volcanoes. But as a global community, we need to do it. We need to do it on an ongoing basis. And I think the recent work of WMO and others creating the Alliance for Hydromet, so the Systematic Observations Financing Facility, it's a really nice example because it sort of recognises that you have a global approach to taking observations. And speaking of observations, again, WMO have led the world for a long time in the sharing of observations. Not all observations are shared in Hydromet, but that is the default. And there's been a huge recent initiative to really improve that into the future. In the world of earthquakes and volcanology, data is not necessarily shared. As a meteorologist, that can be a bit shocking to encounter. The degree of sharing that sometimes doesn't happen. So how can we make sure that all relevant observational data is shared to the specialists, the scientists who need that data to make their decisions? How can we make sure the volcanologists get all the remote sensing data that they need, for example, to go alongside the surface observations that they have? How can we ensure that the data flows back the other way relevant and that everyone is happy with their degree of control over the data and that they're not going to be gazumped by someone seeking to publish from the data and all those things? There's a lot of work we could do there. And then similarly for cross-border warnings, for everything in addition to aviation, how can we put systems in place that take the best of what we already know about multi-hazard early warning systems and do that consistently for all of these things. So I've been talking WMO things a lot. And again, what could we add to this diagram that says, hey, along with calculating ash dispersion, we're going to calculate ash fall, because actually the VACs need ash concentrations in the future. The people need ash fall data in the future, and we've got all these global modelling systems that could really help do a lot of the heavy lifting, working with volcanologists and other things like that. How could we combine these observations in real time? You know, this is a research visualization at Sakurajima in Kagoshima, but how can we ensure that everyone gets a radar view of their eruption cloud in real time? How can we ensure that every potentially tsunami-genic volcano has a lot of information that goes alongside it, so that when one of those volcanoes starts to become active, everyone in the region knows and starts running their drills and contingency plans, and the maximum amount of information is available to the people. Another one, a nice paper of 8 years ago, Jutzler. This quote really got me when I read it. Again, it's the marine community saying, hey, what's going on? We need to forecast pumice raft dispersal. We can do it. It can be detected on remote sensing. It can be modelled. You've got the VACs happening. You've got the International Airways Volcano Watch. How about we do this for mariners as well? And yes, it absolutely could be done. We just kind of need to work out how to get those sorts of arrangements in place. So just getting to the summary stage now, what the paper suggests is a whole lot of dot points around how we create this cycle of building common purpose, coalition I mentioned, starting with some pilot projects and then sort of iterating, and then through that process trying to build a coalition of international agencies to eventually get better early warning systems in place that sort of cover these multidisciplinary events. I want to end with a couple of encouraging points. So I've talked so much about how hard things are, but we also need to remember that international science cooperation works. This example here, it's a verification diagram for the European Centre for Medium Range Weather Forecasting model. The important thing to understand here is that between the time of Pinatubo and the time of Hunga Tonga Ngahapai, the forecast skill of a day 5 forecast in both hemispheres comfortably exceeded what used to be the forecast skill of a day 3 forecast. And likewise, we've got a 10-day forecast coming into frame here, as good as a 7-day forecast at the time of Pinatubo. So even in this really heavy, hard work of international cooperation, it does work. Things do get better. And we can make our warning systems better too if we're systematic about it. And you know, at the user side, being an Australian, I should acknowledge the enormous amount of work that's recently been done in Australia to bring together warning alerts for people, warnings, hazards, action statements, putting them together in a consistent way for every kind of hazard around the country. And that's come together in the last couple of years too. But it's come together after an incredible amount of cross-border negotiation between the Australian states. And I imagine that everyone involved is a bit battered and bloody at the moment, but it's been well worth it. That's the kind of work that we have to do internationally as well in some circumstances, but the results will be well worth it. Okay, so summarising. Volcanoes produce cross-disciplinary hazards that need to be managed within cross-border multi-hazard early warning systems. Volcanic agencies do need more systematic global support. Global arrangements don't currently exist to make this happen. There are similar issues for other geohazards that I haven't really talked about that much, but you know, rain and landslides, for example. With enough willpower, we can change this. I won't read out that whole paragraph, but I think it's important that we assert that through our ground level relationships, through creating good pilot projects, we can bring action here. It's not going to magically happen unless we do put a lot of effort into it. And that's my last point. If we don't think about the international factor when we are doing this, we just sort of let things develop. What will happen is that the richer countries will create better and better individual warning systems for the various hazards. But then after that, it'll be very hard to bring those structures together internationally, because we'll spend 20 years arguing about what colour to use, or what term to use, or other kinds of thresholds. It's much better if we do this work with an international end in mind, if we possibly can, and that will achieve much faster outcomes. So the link to the paper is there, but also for the volcanologists and interested parties here, Graham Leonard and I are running a workshop on this at IFC in Rotorua in early 2023. And the workshop announcement just sort of went up recently on the page. So if you're going to IFC, please consider coming to our half-day workshop. That's me. Thank you very much for your time.
Great. Thanks a lot, Andrew. That was a very interesting and very comprehensive presentation. Thanks a lot. I would like to open it up to the floor for any questions or discussions that people would like to have. Comments. Just feel free to unmute, and I see your hand raised by Beth. Beth, take it.
Yeah, thanks, Andrew. Great talk, and very thought-provoking. In terms of bottom-up or ground-up development to try and establish and grow these collaborations, which coalitions of agencies would you start with? You didn't sort of nominate any, but if you were going to get this going, who would you talk to?
Diplomacy restricts my answer a little bit.
Okay. Oh well, sorry. I'll retract the question if it's a problem.
No. But that's okay. I think there are some really interesting models around. I don't think we have Iceland in the room, so let's talk about Iceland. The Icelandic Met Office did a wonderful job of bringing together the different multi-hazard roles of the agency, and that was agencies being combined, and then restructuring not by discipline, but more by function, and then creating structures to ensure that everyone came together and doing a change process around that. So they're a nice example of a small country where they're able to work out an integrated approach. I mentioned the US and New Zealand. They're both great examples where you have sort of strong separate agencies that would bring powerful voices to the table. The Philippines is another interesting case. So the Philippines have got a bit more of like a hybrid where you have separate volcanic and meteorological agencies, but they're in the same department, led by Renee Solidum, who's a volcanologist and who's now sort of in charge of Pagasa, the meteorologists as well. Vanuatu is another country a little bit later. So we've got kind of role models around the world of good ideas and good practices. And my thinking is that from the operational sense, those kinds of countries would probably be really good players to drive things along internationally. But then it's a case of, well, how, and I'm not the expert here, how do we ensure that views from those countries are replicated in WMO, but also in ISC, UNESCO, in ICAO, UNDRR, and so on. How do we coordinate that? And I don't really know the answers there, but I know that the story of our development of warning systems internationally is ultimately the story of passionate individuals who have worked together across the world to make things happen. And I guess what I'm trying to say here is that we could empower ourselves more to do that.
Thanks.
Thanks. Anyone who wants to respond or other questions, Sylvia?
Good morning, Andrew. I'm Silvia De Angeli from the University of Genoa. Thanks for this talk. I was just wondering if, let's say, impact-based early warning systems can be, in your opinion, an option, let's say, to try to overcome this kind of barrier of, let's say, these separate hazard approaches to early warnings. I mean, I was just thinking, we are really like talking a lot about this impact-based early warning and how this can, say, help in going, say, in a more like multi-hazard direction. So I was thinking, what's your opinion about it?
Yes, very much. I guess we're already seeing a lot of really good things happening there. I mean, WMO, I mean, I'm a meteorologist, so that's my bias. WMO has been doing a lot of good things with impact-based early warnings, but it's also great to see contributions from others, including volcanologists, into that process, and of course, including social scientists into that process. So I think one of the great things about impact-based early warnings is that it helps puts us in the shoes of the user, and allows us to think beyond our disciplinary boundaries much more easily when we're in the space.
Other questions or comments? We have time for one more if we want anything, and otherwise we'll wrap it up. No more hands raised. All right, Andrew, thanks a lot for your presentation today. This was very, very nice. Like I said, it will be posted on our YouTube channel. I'll just share the link in the chat for those of you who maybe missed past. Oh, Robbie, can you? Oh, sorry, I have the wrong link. Sorry. In case you missed past ones, and this one will be uploaded in case you missed the beginning. There you go. We're going to take a December holiday break, and so we'll be back in January with our next session, and we'll advertise it over social media and on our risk listserv. But for now, Andrew, thanks a lot for being here, and I hope to see you all in January for the next one. Thanks.
Pleasure. Thank you.